So Python, I've shown you that we have variables. I could say number equals 5, and that's going to print out 5. And run this by typing Python lists, and there's 5. Let's say we want to have a collection of data, though, like a list of data. Let's say we're like looking at a lake, and we note down all the different species in that fish. We come home to write a program about it for some reason. So we're going to say the fish types in this lake are going to be equal to the following list. So to make a list, the syntax is as follows. Do an open bracket, and if using Visual Studio Code, it'll bring up a close bracket conveniently for you. And now we're going to put in all the objects that are in this list, as in the fish types. So let's say there's a trout, so I'm going to type a string literal, which are the double quotes. We'll say trout, like that. We'll say comma to put the second element, the second item in this list. We'll say bluegill as our second item. For our third item, we'll put in bass, just like that. We're gonna, instead of printing out a number, let's print out the whole list. Let's print fish underscore types, just like that. Come back over here, run it, beautiful. We have trout, bluegill, bass. It's our list that's been printed out. Life is good. Let's say we want to get the second object in the list. We're going to do what's called indexing. Indexing, instead of putting fish types there by itself, we're going to put an open and close bracket, and then we're going to put in the index of the list that we want. I'm going to get the second value, so I'll put in what we would think would be a 2, but this is actually not going to give us bluegill. It's going to give us bass. So let's watch this. It says bass. So you might be asking, why is it 2 to get the second element? We're getting the third element. The answer is because when we're talking about lists, when we're dealing with them in any language, the first index is not going to be 1. Trout is not 1. Trout is 0 when it comes to indexing. So if I want to get bluegill, the second value, I'm not going to put 2 in. I'm going to count up from 0, trout is 0, plus 1 on bluegill, bluegill is 1. I'm going to put in 1. That's going to give me bluegill. There it is. If I put in a 2, that gives me bass. There's bass. And then if I put in a 0, that will give me trout. Just like that. So that's how we index on a list. We get specific values in it. Now you might say, well, there's 1, 2, 3 values in that list. What happens if I put in a 3? Let's do it. And it gives me an error. It says index out of range. Because there's index, the 1th index, the 2nd index, and then there's nothing. So if we try to index outside of this, it's going to throw an error, an index out of range error. So if I put in 30, it'll be the same thing. Same thing. All right. So that's how we access the elements of a list. Let's say we want to get the first element. That's always 0. We just covered that. And again, and it says trout. In case you didn't see that. There we go, trout. Now let's say we don't know how long this list is. Let's say that someone else wrote this code, or maybe it's dynamically created. The list has X amount of items in it, but we don't want to get the first, we want to get the last. We can do this. To get the very last element of this list, we can type -1. Now let's run this. There it is. It says bass. So you might say, well, -1 is out of range, because that's the 0th index, that's the 1st index, that's the 2nd index. There is no -1. Think about it like this. 0, 1, 2 is counting up, counting from left to right, Python has decided that -1 is counting from the opposite way. So -1 starts at the end of the list at Bass. It starts counting the other direction. So if I put -2 in here, that is going to give me bluegill. There's bluegill right there. And so -3 for this list will give me first element, which is trout. But -3 doesn't give you the first element all the time. If there's more than 3 elements in here, then it's going to give me 3 elements counting from the left-hand side, or right-hand side rather. I guess this is right-hand side for you, going this way. So this will give me trout in this case, but we'll see if I put something else in there in a minute, it won't be that. So there's trout. If I put, I don't know, I don't even know like if this is a freshwater or a saltwater fish, but I'll put in salmon. No, I don't know how to spell that actually. I'll say tuna. Might be a dead tuna if it's in the wrong water. And there it is, it's trout, because -3 is counting from right to left, from bass over to trout. If I put a -4, it will give me tuna though. There's tuna. Excuse me. And there's tuna. If I put in a -5, and I run this again, it should give me index out of range. And there it is, list index out of range. So it doesn't matter if you're counting from left to right, 0 up to however many, or from right to left, -1, going further to the negatives. If you put a value that's outside the range of the index, it will tell you that you're trying to access something that does not exist. Okay, and that's positive and negative indexing. Done. We know how to make a list. We know how to index it and get items out of it. But how do we add things to the list if we want to do it during runtime when our program is running? So here we did it while we were coding it. But let's say we want to add tuna later. So I'll go ahead and remove it here. Let's say we want to do that after we print out the whole list. We're going to print out the whole list here. Now we're going to add something to the end of the list. So I'm going to say fish_types dot to access a function that is native to lists. Native as in built in. It's already there. So we use type dot to access a function. We're going to say append. This append function says take whatever you give me as input and stick it on the end of that list. So if I put tuna here, tuna with an A, and I print the list out after I append, save that, go over here, run it. There we go. First list has trout, bluegill, bass, just like we defined on line 1. We just had put a tuna at the end of that list. Now print it out. And there's a tuna on the end of the list, just floating there. And we can even put stuff in here that's not a string. Just as a reminder, whenever we use double quotes, that's a string. It can be thought of as just plain text. That's how the compiler or the interpreter for the language is reading it. So if we want to put in a number, we can do that. We can say fish types dot append, and we'll put in 10. For some reason we chose 10. And let me copy print line real quick and put it at the end as well, so we can see what happens to it. I'm going to clear this out, run it again. Look at that, we have the first list we first initially made. We've stuck a tuna on the end, and then we stuck 10 on the end. So we can actually mix our types in Python. In other languages, we don't have this luxury, but in Python we do. And in other languages, it's more strict on what you can put into a list and what you can't. And there's whole debates on the efficiency of that, or like which one's better or not. But this is an introductory course. We're not here to get into that for now. But just in Python, you can mix your types in your lists. You can have strings, you can have characters, you can have integers, floating point numbers. You can mix them and match however you want. All right. So if we can add things, we can also remove them. So let's say I want to remove the first element. So I'll say fish types dot remove tuna. Remove tuna. Oh, actually trout. Trout is the first item. Trout. Oh my gosh. All right. So we're going to remove trout. Run this. Now it's gone. And we can remove other things too. We can say remove, copy that remove line real quick, paste it. Let's tell it to remove Bass. Now, after that, we'll put in this print statement. We'll run it again. Okay, and so we're missing trout. Trout's gone. And then the second to last line, we have bass, but in the last line, there's no more bass. We removed it. We have bluegill, tuna, and 10. We can remove 10 as well. Okay, so that's how you can remove items. And there's more we can do. We can add things into the list, but that doesn't have to be at the end of the list. We can put things in the middle of the list or at the beginning or wherever we want to put it. We can use the insert function for that. So I'll say fish types dot insert, and then we're going to put in the index that we want to insert at. So I'll say 0. And now we're going to say, because that's going to put at the beginning, now we're going to say what I want to put in there. Let's put bass at the beginning. And let's print out fish types. Let's go over here and CLS to clear. There we go. Okay, so let's track through this list. We defined it here on line 1. We added tuna onto the end of it. We add 10 onto the end of it. We remove trout, and then we remove bass. And then we insert bass back into the list at the first element. So let's see if that happened. Good there. Tuna was added to the end. 10 was added onto the end. And then we removed trout from the beginning. Then we removed bass from its position. But then we add bass back in at the first element. So if we're using insert, that first parameter of insert is the position in the list. And then bass is the actual thing we're putting in there. To add something onto the end of the list, we have to index outside the size of our list. So we had 3 elements in the list here on line, well, whatever line that is right there. And I told it to insert it at index number 3. So if we remember, bluegill is index 0, tuna is index 1, 10 is index 2. Index 3 doesn't exist up here, not yet. But when we use insert, we can tell it to index on 1 plus the amount of indexes there are, and it will create that for us right there. So it won't throw an error on insert. If you want to look up more you can do with lists, feel free to do so. But that about covers it for lists. We'll be moving on to other types of collections of data like tuples later on, and I hope to see you there. All right, that's it for now.